Hey everybody, Fred here at PLCGurus.NET. So you're watching our C HMI video series, and hopefully you've been following along in the previous videos because we are building on previous videos throughout this series here, at least until this point anyway. And you'll know, if you have been, in the last video, we've been slowly developing this little test project type application that's going to perform some various tasks to exploit some of the power of C# and the .NET framework, as well as the Gear.NET class libraries. So you'll know that in the last video, we went ahead and coded a brand new class, the CPUState class. And remember, if you go over to the form, we had basically two group boxes set up here. One of them is the CPU properties, and again, these are those properties that are not likely to change at runtime dynamically. You know, we're talking things like the product code, the serial number, the model, the firmware version running in the controller you're connecting, these types of things. And we went ahead and developed those in a void method that we simply call once our application starts up, read those values in, and display them for our end users. So in this video, we're going to be implementing the CPUState class that we developed in the last video, and these are those properties that we want to dynamically update at runtime, meaning they are or can change and may be likely to change at runtime. Just quickly looking at the CPUState class, and again, I'm just going to take a quick look here. If you want to know a little more information about what we did here, please watch the previous video. However, we did go ahead and, I would say, break out and start to use proper object-oriented type programming to do so. Okay, so we have things like getting the CPU OK state. So we have various tests that we're going to perform in this method. And we have the fault state, and there are various indicators or messages that we can monitor in this method. And then lastly, the key switch state of the CPU, whether it's in run mode, program mode, or remote run mode, respectively. So now it's time to start implementing that new class, and I'm over here in the main form, or form1.cs class here. This is our main form. And to do so, we first have to go ahead and create a variable that we can use to instantiate that new CPUState object that we created in the last video. So I'm going to go ahead and call it private CPUState, and we'll call it my PLCState. And that'll be sufficient for now. So this is, again, the variable that we're going to use to instantiate the CPUState object. So now what we want to do is head on down to the thread method, where we actually are going to be dynamically triggering the updates to be performed, right? So remember, we had this trigger tag update, and this is an actual separate thread from the form thread that we are going to use to update at some given interval. And we did hard code that sample rate right here. So the private const double tag, and I mean, we could make this changeable as well, right, via the HMI if we wanted to. And you know what, maybe we'll bump this down and get a little more aggressive on that sample rate, and I'm going to go ahead and change that to 200 milliseconds while we're here, right? So every 200 milliseconds now, the event handler for this trigger tag update thread is going to fire, and it's going to go ahead and grab our tag value window data, as well as now we're going to go ahead and program in the CPUState values here. Okay, so bear with me. There's a little bit of coding here to do. So short musical interlude. All right, let's do that, and we'll get right back to it. We'll code this in, and I'll come back and explain what we did. Okay, so we're back. Oh, it looks like we have another little issue with the semicolon. Those darn semicolons. Okay, so it looks like it's on line 121, which is right down here. Oh, I put the semicolon in the wrong place. Silly me. Again, this is why using a proper IDE is indispensable, and Visual Studio is by far the best IDE, in my opinion, that's out there, bar none. Okay, so we don't have any errors, so that's a very good sign. So let's just talk about what I did in this little thread method to update it so that we can dynamically monitor the CPU state in our form, okay? So you'll notice right off the hop, I put it all in a try-catch statement. You don't want your software to crash for some unexpected reason that you never anticipated seeing. And so sometimes it makes sense. I mean, you want to create those fault handlers and all those things and control it, but in the event you don't know what to expect, or in the unlikely event that something creeps up that you're not aware of, a try-catch is a way for your application to tell the user, hey, there was some problem we weren't expecting. It's a high-level exception. Here's the message. Here's the call stack. And this can help troubleshoot. So again, you want to build those fault routines in as much as possible so that your system or your software is very robust. However, when you cannot account for every single issue that's going to creep up, the try-catch is a kind of your last resort type of method of catching those system errors, okay? So anyways, again, if you want more information on try-catch, do a Google search, do one of those things, but they are useful in those situations. Okay, so we put everything inside here in a try-catch statement. Again, this is the exist statement. We'll just comment this. Read. So this is the existing read of the analog tag for the main tag value window, I think we called it here. So we'll just put a quick comment there. And then this is the part that we really added that's new. So again, similar to the CPU properties, remember this special token or string tag name that we assign to grab the CPU info properties. This is a special sequence of characters that InGear will recognize and return this array of information. So likewise, it has one for the actual CPU state values, and very similar in nature, $CPU_state. And again, this is a special token or special string that tells InGear's libraries that you want to get that CPU state information, okay? And again, we use the standard ifMyPLC.read tag, and this time we're after the CPU state. If we have a good read, we're going to go ahead and instantiate our new CPU state class that we created over here, and we're going to go ahead and populate that constructor method. Remember this constructor up here? It's an overloaded constructor that took the array of int32 state values. Okay, so we're going to do that all in one nice clean call here. So we're instantiating and initializing our internal state value array. Okay, I hope that's clear. And then we just proceed at that point to populate our form, all the different fields on our form, here, here, and here, these text boxes, by making our method calls, our getter method calls, for the various OK, false, and key position. And remember, our CPU state class that we created does all of the heavy lifting here for us by parsing it out, figuring out what exactly is in fact going on with our CPU. Okay, so again, I hope that's clear. Then we just have some control type handlers. Okay, if we didn't get a successful read, let's show the user why we didn't get that successful read. And then let's just populate those text boxes with question marks. And, you know, hopefully we can sort it out from there. Okay, so I think we're at a point now where we can actually try this. So let's give that a shot. Okay, so you see I've got RSLogix 5000 open here, and I'm connected to the controller, which is in remote run currently. And again, this is just an empty program for now. I'm just in the controller tag database because we're monitoring that tag real which is actually the tag value window tag that we're actually monitoring over here. Okay, so let's go ahead and launch up our application here by clicking the Start menu. And I'm just going to move this over here so we can get everything in kind of one nice little view here. All right, so let's go ahead and attempt to connect now to the controller and see what happens. Okay, oh, wow, look at this right away. I can't believe we didn't have any issues here, this is not post-processing, this is great. Okay, so it looks like we've gone ahead and populated the CPU state. Okay, we've got our tag read, we've got all of our CPU properties that we did in our initial call. Let's just go ahead and play around with this number, I guess, just to make sure that we're actually reading it, and it looks like it's going really well here. And remember, we did increase that sample rate to 200 milliseconds, so now we're reading quite quickly, aren't we? Okay, so I'm going to go ahead and reach over here, and let's put the controller into program mode. And right away, we see that the key position went to program. Okay, this is great. And we have the flashing green. It's not actually flashing green. I just realized the Control-Logix processor here doesn't actually flash green when it's in program mode. But again, we can edit that because that's just our string values that we've put in there in our CPU state class, right? Okay, so I'm going to go ahead and just kick that into run mode. And you can see it's in run, it's solid green. Okay, perfect. And let's go back to remote run. Okay, this all seems to be working really well here. So let's figure out a way. Let's see if we can actually fault this processor. You know what? Probably the easiest way to try that is just to go into the properties and to trip up the watchdog timer. So I'm going to put this at its absolute minimum of 0.1 milliseconds. And it looks like our max scan is well above that. So we should fault out. And there we go. We see the processor's faulted. We have a flashing solid red major fault in the controller. It's an unrecoverable fault. So this is perfect. So I'm going to go ahead and kick this into program mode now. And you can see I did that. And that's still responding the way we would expect. Okay. And because it's an unrecoverable fault, there we go. I just kicked it into program now. Again, I'm just playing with the key switch here, but of course we can do that just as easily by going into the fault drop down here, little processor flyout. Let's go to the fault, and of course we know it's the watchdog, so we don't have to really do that. So let's just go ahead and clear that fault. That should kick us right into program mode or remote program mode, and you can see it did update here that we are in program mode. We are still remote run because that's the key switch position. Let's go correct the watchdog timer now. We'll put that back at the default 500 milliseconds. Apply, click OK, and let's go ahead and put that back into run mode. Okay, so no fault, solid green. Everything looks like it's working well. Just for good measure. Okay, good. So I think that's it. I mean, there are other things we could do. I mean, we could do firmware upgrades. We could do all of those things to check and test all of the different states. And again, I assure you that the states should work as we've programmed them, according to the literature from Ingear anyhow. So I hope you found this video informative. Again, this is Fred from PLCGurus.NET. Please do subscribe to our channel, ring that bell, give us a like. Put some comments down if there's something you want to see specifically to C HMI and developing this stuff. Go ahead and put that in the comments section. And please do head on over to our companion website at https://PLCGurus.NET. Become a member of what is quickly becoming the largest and fastest growing community of professional engineers, technicians, and technologists who all share that passion for industrial automation and control. So subscribe, like, check out the website. Thanks for watching.